Where's the possible outcome?
All
So
right.
this is what I've done here. So like 1 is wrong, 2 is right, 3 is right, 4 is right. If X is wrong, either 1 is yes, 2 is
So-
right, 4 is yes, and then I just
Dude, I'm lazy, I'll do it.
7B. All right, so I said 7A is talking about the difference between the two types of random variables, and from now on we're just looking at discrete random variables, and that's what we'll be focusing on for this test. So I'll just talk about, I encourage you to read this text here. It will pop up in our examples, but I'm just going to point out two things. That when we're describing probabilities of events, all probabilities occur between 0 and 1, okay? So the probability of 0 means it's definitely not happening, and the probability of 1 means it's certainly going to happen. Okay, probability of 0.5, 50% chance of happening. All right, and then the other one is that the sum of all probable events equals 1. Okay, so the probability of each event occurring added together will always add up to 1. So here we're presented with, in our example, we'll have mode and median and mean pop up as well when we reach it, but let's get straight to the example. Consider the probability distribution below. Okay, so X here is the events. Okay, so the events of this probability distribution, it might be you're rolling a dice, it might be you're spinning a spinner, whatever it is. The events are, you can get a 1, you can get a 2, you can get a 3, or you can get a 4. The probability of getting a 1 is 0.2. The probability of getting a 3 is 0.24. We don't know what this is yet, but we can calculate it, and that's what we're required to do first. How can we calculate it? We know that all of these probabilities must add up to 1. 0.2 plus k plus 0.24 plus 0.22 equals 1. Solve this for k. What's that going to be? K plus 0.66 is 1. K is 1, take 0.66. K is 0.34. Now this is a 1 mark question, all right? So you don't get any marks for showing this working out. You just get a mark for getting the correct answer. Okay? The value of k for this probability distribution, to make it valid, is 0.34. Okay, so for it to be valid, all of the probabilities add to 1, and each probability lies between 0 and 1. Okay, that's what makes it valid. Okay, that's part A. Part B, is this a uniform discrete distribution? Okay, so that word uniform means all the same. All events have the same probability. Do all of these events have the same probability? The answer is no. Okay? Uniform, no. Why? Not all events have the same probability. Okay, an example of a uniform distribution would be rolling a dice, right? If it's a fair dice, you would expect each event to have a probability of 1 on 6 of occurring. Not all events have the same probability. Alright, so uniform is when all events have the same value of p. Part C. Find the probability of the events, the value of x. Alright, so let's just talk about what this language is. X is the event, and this is the probability that when we perform a sample, alright, when we perform the test, it takes on that event. Okay, that's what that language means. It's just the probability of that event occurring. Now, we're asked specifically, find the probability of the event being 2 or larger. That's the probability of this region, right? The event 2 plus event 3 plus event 4. All right? So probability of event being larger than 2 is the probability of event 2 plus the probability of event 3 plus the probability of event 4. And notice how that is the same as, we know all of these probabilities add up to 1. And so just quickly in my head, rather than adding those up, 3 things to add up, I'm just doing 1 take away that. Because that's going to leave me with this component, this part here, point A. Very good. So that's part C. Okay, now let's talk about mean, median, and mode. Okay, mean we will do in 7C.3. So you don't need to do mean yet. It will come up, mean of probability distribution. Okay, let's do the mode first. The mode is just the event with the highest probability. All right, so we're looking along. Which event has the highest probability? 2. So the mode is 2. All right, that event is more likely to occur. So mean we'll do later. Mode, event with the highest probability. And if there are, you can have multiple modes, right? Multiple modes when there's two or more events that have the same probability, that's also the highest. It's just whichever event corresponds with the highest probability. And then on to median. Okay, median is a little bit tricky, so let's read exactly how it's articulated. Just above where the bold, where I've got example problems, just above that, about 3/4 of the way down the page. The median is the event that corresponds to the cumulative sum of probability reaching 0.5. Okay, so what that means is we start at the lowest event and we add the probabilities up until we reach 0.5. So if I've got 0.2 plus 0.34, that's going to give me 0.54. Okay, so when I add these probabilities together, I reach or exceed 0.5 during this event. So the median is 2. All right, we'll have more of those pop up. Find the mode and the median. Done. Very good. Okay, turn the page. So we'll start off with some fairly basic probability distribution functions. Just to stress, all right, for it to be valid, all probabilities must lie between 0 and 1. That means you can't have a negative probability. All right, no event can have a negative probability, that can make sense. And that all probabilities must add to 1. Okay, so in this example, all right, here we have distribution tables. Sometimes we will express them as a function. This is a probability distribution function. All right, and so what we're told is, here's the function, and this function is valid for values of x, 1, 2, and 3. So what that means, okay, what it means is that P of 1, the probability of event 1, plus the probability of event 2, plus the probability of event 3, will equal 1. All right, the sum of all probable events must be 1. These are the possible events, and when we add all the probabilities together, it will be 1. So part A says find the value of k, and then part B wants us to draw the distribution. All right, so if we're going to find the value of k, I'm going to substitute the number 1 in here. That's going to give me P of 1. So P of 1 is k on 4. P of 2 is going to be 2k on 4. And P of 3 is going to be 3k on 4. And all of that together will add to 1. And we're just solving this for k. This gives us 3k, 6k on 4 equals 1. All right, now probably when you're confronted with this, you'd think of doing it in 2 steps. You'd think, oh, first times by 4, then divide by 6. Do it at the same time, all right? We're trying to get k by itself. We're going to multiply by the reciprocal, right? Multiply both sides by 4 on 6. We've got 6 at the top, 6 at the bottom, 4 at the top, 4 at the bottom. And so our answer for k is 4 on 6, or 2/3. All right, so that's the value of k. Now, let's draw the part A, find the value of k, done. Part B, draw the probability distribution. So, here's our events, right? Our events are x is 1, x is 2, or x is 3. Okay, they're the discrete events. And then here we have, what's the probability of those events occurring? What's the probability that the random variable takes on that event?
What's k plus 2k plus 3k?
Okay, so for the probabilities in here then, all right, now that we have a value of k, now that k is 2/3, all right, we can evaluate, well, what's the probability of 1? It's 2/3 on 4. All right, 2/3 on 4, which is 2/3 on 4 on 1, AD on BC, 2 on 12. All right. The same with probability of event 2 is 2k on 4. All right, so let's just write that out here, 2k on 4. That's the same as 2 times, well, k is 2/3 on top of 4. So I'll do it nice and slowly. You can just type in your calculator, right? We'll have 4 on 3, on 4 on 1, AD on BC, we'll have 4 on 12. Okay. And then for the last one, you can complete it again, or you just know that all of these must add up to 1. So that's going to be 6 on 12. Now you can simplify as you're going along. You can simplify these probabilities, but I would encourage you not to, because we can see very clearly now that because they have the same denominator, that when I add up the numerators, it gives me 12 on 12. So if we keep them with the same denominator, that's going to be useful a bit later on. Okay, part C, find the median and the mode. Okay, the mode is the event with the highest probability, so the mode is 3. The median is the event such that the cumulative probability reaches or exceeds 0.5. So here we have 2 on 12 plus 4 on 12, that gives us 6 on 12. All right, so the median is 2. Very good. Okay, so that's enough to rip into 7B, and that's what we'll complete for the rest of the lesson today.